This week and next week, we're going to skip ahead and we're going to do a topic from year 11. And the topic we're going to do is to do with the rate of reaction. In the textbook, it is chapter 5.1, which you can read about on pages 146 to 155, which I would strongly recommend that you do. So, we're going to do this because it just makes it slightly easier. It's a slightly easier topic to deal with remotely. There are some experiments involved, which we'll do probably in September. But let's just get to it. So, when we talk about rate of reaction, we're talking about how fast reactions happen. So, up until now, we haven't really thought about the speed of a reaction. We've thought about what reactions can happen, so acids and alkalis, metals and acids, that kind of thing. We've thought about the energy changes in reactions. Are they exothermic? Are they endothermic? Is heat being produced? Is heat being absorbed? All that kind of thing. We've thought about what happens to the electrons in chemical reactions. Are they being shared? Are they being transferred? But we've not really thought about how fast reactions are happening. So, how can we work out how fast a reaction is happening? Well, there are two ways. Okay, so the first way is we can think about how quickly are reactants used up. Or we could think about it the opposite way, and we could think about how quickly are products produced. How quickly are products made? Okay, and both of these will give us a rate of reaction, an idea of how fast a reaction is happening. And for any reaction, these should be the same. So the speed at which the reactants are used up will equal the speed with which the products are made. Okay, it's not possible for you to make products quicker than your reactants are used up. That's just not possible. All right, but you'll see later on that in terms of measuring the rate, we can either measure how quickly the reactants are used up or how quickly the products are made. So let's suppose that I have, I go camping, okay, and I have a propane gas canister. Okay, so this is my propane gas canister, which contains propane, C3H8, that's my propane. Okay, and I am camping, so I probably want to, make some super noodles or something, or heat up some water for my cup of tea in the morning. Anyway, so I'm going to do the combustion of propane. So C3H8 plus O2 goes to make CO2 plus H2O. And that equation needs to be balanced. So if I balance that, I've got 3 carbons here, so I need to have 3 carbon dioxides because there's a carbon here. I've got 8 hydrogens. Each water's got 2, so I need to have 4 of those. And now I've got 6 oxygens here and 4 oxygens here is 10 oxygens altogether, so that needs to be a 5. Okay. So this is the reaction. This is the reaction that I'm doing. Now, let's suppose I want to get an idea of how fast this reaction happens. Okay. Now, what I can do is I could measure the mass of my propane gas canister. Okay, so I can say mass at the start equals, let's say, 500 grams. And then I use it for, let's say I make a cup of tea, so I'm going to boil some water. I use it for 2 minutes. So I burn it for 2 minutes, then I turn it off and I measure the mass again, and the mass has gone down to 450 grams. So now I can work out the rate of this reaction, okay, because I've done it for 2 minutes and I've lost 50 grams. So I can write out that the rate of reaction equals the amount of reactant used divided by the time taken. And if I do that, the amount that I used was 500 minus 450 divided by 2. So if I work that out, that's going to be 50 divided by 2 is 25. Now, you have to have units for this. So the units for the amount of reactant used up is grams. And the time taken was minutes. Okay, so I'm using 25 grams per minute. 25 grams per minute. So that's quite a straightforward calculation. I'd just like you now to have a practice at doing that calculation. The most complicated part of this calculation is going to have to be making sure you get the units right. So for each of these questions, we're burning propane, C3H8, all right, and I want you to work out the rate, find the rate in grams per second. So how much propane is used up in grams per second. So pause the video and have a go at these questions. Okay, so you should have done those by now. So if we now work out the rate for each of these, so the rate for this one, I've got grams and I've got seconds, so it's easy. So it's just 10 divided by 20 equals 0.5 grams per second. For this one, I need to convert my 0.1 kilograms into grams, so that's 100 grams, and my 40 is in seconds, that's fine. So my rate is going to be 100 divided by 40 is 2.5 grams per second. For my next one, my amount of propane used is in grams, so that's fine, that's 100. And my time here is in minutes and seconds, so that's 150 seconds. So I do 100 divided by 150, which is 0.67 grams per second. And for this one, I need to have this in grams is going to be 2400000 grams, and 10 hours, well, 10 hours times 60 minutes times 60 seconds is going to be 36,000. So if I work out the rate for that one, it's going to be 2.4 million divided by 36,000, which is 66.67 grams per second. Okay, so you can see that, you know, these are maybe, this you might happen in the lab, this might happen, you know, on an industrial scale, but the calculation is the same in all cases. So it's really important that you can just get an idea for what this number means. So it means that every second, half a gram is being burnt. Over here it means every second, 67 grams is being burnt. So that's quite a lot. Okay, so you hopefully can see that this, it's quite like, it's a rate, so it's similar to speed, isn't it? So if you think about the speed that you run at being meters per second, this is the speed that the mass of propane is used up. Okay, so that's just the introduction to the concept of rate. In the next video, I'll start talking about actual experiments that use this.